Trapezoids and kites. Trapezoids or kites are not parallelograms, but they do have some unique features for quadrilaterals that we're going to talk about. First thing, a trapezoid has one set of parallel sides. It's called the bases. You have the top and the bottom, in this case, which are parallel, but the legs are not. So that means opposite angles, opposite sides, all that stuff are not going to be congruent like in a parallelogram. But because we have parallel, these are still same side interior angles. So any two angles on the same leg will still be supplementary. And that's pretty much all you have for a regular trapezoid. When we get to an isosceles trapezoid, just like an isosceles triangle, the legs are going to be congruent. But that also means both set of base angles will be congruent, because base angles of a triangle are congruent. Well, if you think about this, here's an isosceles triangle. You just cut the top off with a parallel line. These are still congruent. But now, because of same side interior angles, those will be congruent as well. The other thing is the diagonals will be congruent. So if you have diagonals in an isosceles trapezoid, those will be congruent as well. So here's a couple quick, simple, easy problems. This one is just a regular trapezoid because you have no legs with tick marks or anything that indicates that it's isosceles. So in this one, the only thing you can do is same side or same leg angles. So this is 110 at the top. Angle 2 is going to be 70. And then if we look over here on this side, this bottom is 30, which means angle 1 is 150 because they have to be supplementary. In the second one, we have that it is isosceles. So since it is isosceles, the base angles are congruent, so this top is also 120. Same leg are still supplementary, so if this is 120, then this guy is going to be 60, which means angle 3 is also going to be 60. So that's the difference between a regular trapezoid and an isosceles trapezoid. Which brings us to the last one in this row. If we're trying to solve for x, your only option is to add those to 180 because this is not an isosceles trapezoid, so we do not know that the tops are congruent. So this would just be 5x plus 30 is equal to 180, which means you're going to get x is equal to 30. And that's it. Here's one that's going to work with some diagonals. So we know that AE is x plus 2. That's this little guy right here. We know that BD is 4x minus 7. That's the whole thing. And then we know EC is 2x plus 5. So because the diagonals of an isosceles trapezoid are congruent, you need to add the two little ones, so x plus 2 plus 2x plus 5, and you set that equal to the big full-length diagonal, which is 4x minus 7. After you do that, you're going to get x is equal to 14, and you are good to go. But then you just have to go back and find BE. Well, that's the top little piece, so you have to plug it into AE, and you get BE is equal to 16. Alrighty? In any type of trapezoid, you're going to have a mid-segment. Now, it's similar to the mid-segment of a triangle. It will be connected by the midpoints of the legs of that trapezoid. But it's not half of the base like it was in a triangle. What you have to do is you have to find half of the sum of the bases. So that's why we have the formula that the mid-segment is equal to 1/2 of the sum of the bases. So it's kind of like in the middle. So to find x, all you have to do is add 8 and 14, which is going to give you 22. Divide that by 2, and you get 11. And then you can check. 11 plus 3 is 14. 8 plus 3 is 11. So it's equidistant in between the two of them. So in this one, you need to think about this. This is half of the sum. So half of what number gave you 9? That would be 18. So what does x have to be to give the bases a sum of 18? and that would be 4. Now, algebraically, what you would want to do is you could use this formula, but the better way to do it when you don't have it would just be 2 times the mid-segment is equal to B1 plus B2. That's another way to look at this. So we could just do 2 times 9 is equal to x plus 14. And you'll still get x equals 4. That's just another way to do it algebraically. So in this last example, that's exactly what you would want to use. You would want to use 2 times your mid-segment and set that equal to the sum of your bases. And that, of course, will give you 4x minus 8 is equal to 3x plus 4, which is going to give you x is equal to 12. All right? So that's mid-segments. Last thing we need to talk about are kites. Now, kites, in a way, are just 2 isosceles triangles connected at the base. So if we had an isosceles triangle here, and then we take another isosceles triangle here that have the same base, and we connect them, that's where we get our kites. Now, kites have a lot of interesting properties. It has the vertex angles in both are bisected by the diagonal, but that is not true for these because obviously these base angles could be different. The top angle is not congruent to the bottom angle, but since this angle is congruent to that and this angle is congruent to that angle, then in a kite, these angles would be congruent. The short or the bases of the isosceles triangles, they get bisected, but the other ones obviously do not because the height of this triangle is not the same height as that triangle. And then the diagonals are perpendicular. So you have a lot of different properties here, but you can't say that opposite angles are congruent because only one set is. You can't say opposite angles are bisected because only one set is. So it does have one set. So the easiest way to think about kites is to think about isosceles triangle properties. That would probably be the best way to look at these. So in this one over here, what you need to realize is all of these guys are 90 degrees again. So if we're looking for the length of AB, you have 2 sides. And every time you have 2 sides, you have to remember, if it's a right triangle, you can use the Pythagorean Theorem. So we can call this guy A and we can call this guy B. So in the left triangle, you are going to do A squared plus 8 squared is equal to 10 squared. And that's going to give you A squared is equal to 36. So then A is equal to 6. So we know that A is 6. Now we have to do the Pythagorean Theorem again with the right side over here. And this would be B squared is equal to, B squared plus 8 squared is equal to 17 squared. And then you're going to subtract 8 squared from both sides. So B squared is going to be equal to 225, which means B is equal to 15. So this guy is 15. So now you know your entire diagonal length, which is 6 and 15. So the length of AB would be 21. So that's how you do that guy. Last example, you're just finding missing angles. So this is where you have to think about your isosceles triangles. So you have a top isosceles triangle and you have a bottom isosceles triangle. So that means first think about your isosceles triangles. This guy's 70, this guy's 70. The other thing you want to think about is the fact that the center 4 angles are always 90 degrees. The other thing you need to think about is the fact that these guys got bisected. So if this guy's 40, this guy's also 40. Well, if you have 40 and 90, you know that these guys both have to be 50. And now you're just going to keep on working from there. So then the next thing you want to do is just remember that you have 70 and a 90. So that means angle 5 is going to be 20, which means this guy is 20. And now you have all the information you need. Angle 1 is 40. Angle 2 is 50. Angle 3 is 90. Angle 4 is 70. Angle 5 is 20. And now ABD would be 50 and 70 combined, so that would be 120. And BDC would be 20 and 20, so that would be 40. Alrighty, and that's it for the kites and the trapezoids. This is Longo, and I'm out. See you, bye.